Okay, hello everybody. So this is my video solutions video for the March mini mock. Let's just get on with it, shall we? So, first question was f of x equals x minus 3 squared minus 17. So it's a quadratic incompleted square form, and it's a functions question. Now what you have to realise in a question like this is that functions can be one-to-one or many-to-one. But, and this is a serious but, if you want the function's inverse to exist, then you have to make the function one-to-one, because a many-to-one function, the inverse will be one-to-many, and that's not a proper function for reasons, basically. Yeah, we're only allowed one-to-one and many-to-one as our functions. So when they give you a quadratic and they ask you to restrict the domain, as they have here, so that the inverse exists, it just means change the values x can be so that it becomes a one-to-one function. Now if we just quickly sketch this function, we can see it's going to have a minimum value at x equals 3, y equals minus 17. Yeah? So in other words, it's going to look something like that. 3 minus 17. I can see that straight away from completed square form. Now currently that function is many-to-one. And you can see it's many-to-one because if you can draw a line, like a flat line, a horizontal line, and it hits it twice, well that's two different x values giving you the same y value. Hence it's many-to-one. And so what we want to do is change it so that that doesn't happen anymore. And that's what we're going to do. We're going to find that value of k, it is right here, k equals 3, to make sure that x is greater than or equal to k. Because if x is greater than or equal to 3, this function is now a one-to-one function and the inverse exists. You could do the same trick with less than or equal to 3, but our question specifically said we wanted x is greater than or equal to 3. So there we go. Okay, for part B, now we've got that, well actually you don't need this for part B, you can just do f of 5. Well, you know, the easiest way of doing this is plug 5 in, you get 5 minus 3 is 2, square it you get 4, 4 take away 17 is going to be minus 13. So what we now need to do is plug minus 13 in, and when we plug minus 13 in we're going to get minus 16, square it you get 256. So I think that's 239 after you take that away. Let me just check my answer. I've got the mark scheme here as well. The final answer should be 239. Good. I was just checking my arithmetic there because I haven't got a calculator around or anything. But yeah. Oh, but hang on a second. Oh, I ignored this, didn't I? This is a catch. I feel like this is a bit of a stitch up, this question, really. What you've got to realise, actually, is 239. No. Because this function is only defined now for x is greater than or equal to 3. So this doesn't exist. That's a real stitch up, that question. As minus 13 is not greater than or equal to 3. That's a real got ya. So watch out for that. I was about to say 239 as well, and I just saw at the last minute x is greater than or equal to 3. Okay, part C. We've got solve the equation f of x equals x. Now this isn't too bad because you're just going to make x equal x minus 3 squared minus 17. Whatever you do, you want to essentially turn this into a quadratic. So if we multiply that out, we're going to get x squared minus 6x plus 9 minus 17. So that's going to become, oh, I've got some syncing problems. No, it's working now. Good. Let's just scroll down a little bit. You're going to get 0 equals x squared minus 7x minus 9 plus 7, plus 9 minus 17 is going to be, what's that going to be? Minus 12, I think. Sorry, 8. Yeah, 9 minus 17 is minus 8. Yeah. Sorry about that brief moment of absolute yeah, horror there where I couldn't do that. Okay, and what you'll notice is this actually factorizes nicely, which often is a good indicator that you're doing it right. And so you've got x equals 8 or x equals minus 1, but x is greater than or equal to 3, and so we've only got x equals 8. Hopefully that's nice and straightforward. Cool. Okay, part D. This is an interesting one for me, part D. Explain why your solution to part C is also a solution to that equation. Well, I think firstly, if you just look at like a function algebra, if you've ever got f of x equals x, what you could do is take the inverse of both sides and the inverse of a function cancels. And so you get x equals f to the minus 1 of x. So that will have the same solution. The geometric interpretation, which is another way of looking at it, you could say, well, when you solve f of x equals x, you're actually going to get the same answer as x equals inverse f of x. And that's because functions are reflections in the line y equals x when you take their inverse. So let's say our original function looks like this. Our inverse function is going to look like that. And they will hit the line y equals x. So this is f of x. And this is the inverse of f. They're going to hit the line y equals x at exactly the same x coordinate. So that's another way you can explain part D. You can just say f of x and the inverse of f will hit the line y equals x at the same point, because they are in fact reflections in the line y equals x. I'm just going to have a look and see what the actual mark scheme did. F of x and f to the minus 1 of x are reflections in the line y equals x. So they took this approach, but I don't see why you can't argue, well, this is just a consequence of, so that's a consequence of how the inverse works. And there we go. So that was the first question. It was a bit of a weird question. The vast majority of people were not getting full marks. Firstly, B was catching them out. I can understand that. I really can, because you just automatically plug the minus 13 in and start doing it, and you get 239. So you're going to, easily lose a mark on that. C, though, isn't bad. There's no reason why you shouldn't be getting C right, and most people were. A's not bad. And D, yeah, it's a wordy one. So, yeah, watch out for that. But honestly, a diagram really helps, and then just explaining your diagram saying f and f to the minus 1 are reflections in the line y equals x, so they will meet the line y equals x at exactly the same point. Okay, let's go to number 2. Sam starts with an annual salary of 16 grand. It's promised that the salary will go up by the same amount. That means it's an arithmetic sequence, it's an AP. So we'll be needing in this question, un is a plus m minus 1d, and sn is n over 2, 2a plus m minus 1d, yeah? Write down the equations as soon as you know it's an AP. Okay, find Sam's salary in the 10th year. So we need U10, and it's going to be equal to first term, 16,000, plus 9 times by, what is that, 1,200. Okay, that's something you can just type into a calculator, and it should come to 26,800. And that should be absolutely fine, yeah. Find the number of complete years needed for Sam's total salary. You see, I don't like the way that question's put, because the salary always refers to how much you earn in a year, but I think they want the sum of all the salaries that Sam has earned here. In other words, we need the sum formula, and we want that to exceed 500,000. But I don't think the question's put brilliantly, I really don't. Okay, so we need n over 2, 2 times 16,000, well, that's 32,000. Plus m minus 1 times by 1,200. We want that to be greater than 500,000. Okay, so I probably times by 2 first. Oh, actually, I might times a half into here. So we're going to get 16,000 n plus 600 n squared minus 600 n is greater than 500,000. And this is a quadratic, so we want it all on one side. 600 n squared. We're going to be doing plus, what is that, 16,000 minus 600, so that's 15,400 n minus 500,000 is greater than 0. Now, I mean, let's get rid of some of these zeros. Cross out 2 zeros on every term. Looks like a nice way to do it. So 6n squared plus 154n minus 5 with 1, 2, 3 zeros, so 5,000 is bigger than 0. I'm now going to it's probably wise to actually just stick that into a calculator at this point, because we can find the roots. We're going to get one negative value, but you're going to get n is 18.8 for the other one. I think the other one's minus 44.4, but we're not interested in that. And so it'll exceed it after 19 years. And that's when you're going to get greater than 500,000. Comment on how realistic this model is in the long term. They just want a sensible comment in the context of the question here. I'd probably say something along the lines of, well, I wish my salary went up 1,200 quid every year. I really, really do. Salaries tend to reach a ceiling. But also, promotions tend to give you a big bump up. A big non-linear, maybe we can put it like that because this is linear, non-linear bump in salary. Yeah, they just want a sensible comment in the context of the question there. That's all they want. Okay, number 3. Okay, these ones are never that popular because they're quite tricky. We can see why it's quite tricky. It's going to be a differential equation question. Remember, when you see a differential equation and you're being asked to solve it, separation of variables will never go wrong, and it's the only technique you're required to know. So if you remember separation of variables, that's what you're looking at in these questions. Now let's read it. Sorry, quick sip of tea. Okay, we've got a cylindrical tank. There's a small hole at the base which water's leaking out from. Okay, right, fine. The height of the tank is x, and that's the height of the water in the tank. The rate of change of the height of the water, so that's dH by dt. When they say the rate of change of the height of the water may be modded by the assumption that it's proportional to, okay, I'll do the proportional sign then, the square root of the height. Now you can always replace the proportional sign with a constant of proportionality. So we're going to have dH by dt is k root h, yeah? And that's good. Now we just need to use their initial conditions, yeah? That is a rate, yeah? And you can see it from meters per second. That is a rate. In other words, that is dH by dt, yeah? So we know that when t is 100 and x is 0.64, and oh sorry, is x the height? So I shouldn't be using height, I should be using x. It slightly annoys me that they use a letter which I wouldn't use there. Makes me look a bit silly. But this is going to be like this, yeah? We're just going to have x's everywhere. I didn't realise they'd already defined it as x. I should have seen that, so I apologise. Okay, so we're now going to plug in dx by dt is 0.0032 when x is 0.64. The square root of 0.64 is 0.8, so you're going to get 0.0032 is k times 0.8. So now we can divide that over there, so you're going to get 0.0032 over 0.8 is k. That sounds like, well, if I times the top and bottom by, yeah, I think that does actually give me 0.04. Let me just reach for my calculator to check all my values are correct. I seem to be struggling with that at the moment. Okay, type it into your calculator, 0.0032 divided by 0.8, and I get 0.004. Okay, the one thing they have got is a negative here, and that's because it's decreasing, so I'm just going to sneak that into my working. Well, I mean, like, yeah, stick that into your working all the way through, just to represent the fact that it's decreasing, and you can now say, hence, dx by dt is minus 0.004 root x. Find the expression for x in terms of t. So this is a separation of variables bit. So what we need to do is put the stuff about root x with the dx and the stuff about t with the dt, and there is no stuff about t, so that's nice. Now it might help if we write this as a fraction. I think it will make the algebra a little bit easier. I'm going to write that x to the half as well. Personally, my preference here is to write that as x to the minus a half dx. I personally leave this minus 1 over 250 on this side because I think it's easier to sort of dump it onto the other side because it will be easy to integrate. And I'm just going to integrate both sides. So I'm going to get x to the 3 over 2 times 2/3 equals minus t over 250 plus a constant c. Now we can find that c because we've got initial conditions. So I'm going to plug in t is 100, x is 0.64, square root of 0.64 is 0.8, 0.8 cubed I think is 0.512, times by 2/3, I think this probably has an ugly answer, 0.512 times by 2 divided by 3, okay, I'm getting 128 over 375, here. So I'm just plugging in these values here, and I'm going to plug in t as 100 over 250, so that's just like 200, 500, 2/5, so minus 2/5 plus c. C ends up being plus 2, 5. Okay, 278 over 375, I think. I'm just going to check my answers here. Let's see. Let's have a look. I'm just plugging these in. I'm just going to go back and check here, because I feel like I've made a mistake here. Let's have a little look. This is looking good. Oh, it's here, isn't it? Look at this. Minus a half, increase the power by 1. You're probably screaming at the screen, good for you. And therefore you're going to get this. But do remember thinking that this has a nicer answer. Increase the power by 1, you get x to the half. Divide by a half, that's the same as times and by 2. Everything else is fine. So we're going to square root the 0.64. It's going to become 0.8. Times it by 2, you're going to get 1.6. When you plug in that, you get minus 2/5, so that's minus 0.4 plus c. So c is actually 2 here, and so your final answer should be 2x to the half equals 2 minus t over 250. And if you want x in terms of t, then you need to divide by 2 and square. So x equals 1 minus t over 500 all squared. And then you've got x. Let me just check my answer now. Yeah, 1 minus t over 500 squared. Cool. Okay, and there we go. That is the answer to that question. Okay, let's do one more. And this one hasn't actually appeared quite nicely on my screen, but I think I can just about make out what it says. So we've got 3 cos 3x minus 7 sine 3x. And this is a basic technique. They love these r cos and sine alpha questions. Now we're going to express this in the form r cos 3x minus alpha. Now if we just expand the right hand side here and keep writing down the left hand side, we can then equate the coefficients. So that's going to give us r cos 3x cos alpha. Oh, hang on, one of these must be a plus, I'm guessing, because otherwise they wouldn't have suggested this kind of thing. Can I just quickly actually have a look at the page, because I need to see what one I actually... Where is the question? 1 second. What have I got here? I can see the question clearly now. Oh, that was a plus. That is actually a plus. So if you can hear somebody screaming from outside, that's just my son. He's always keen to get me out of the shed. He figures that, you know, I should be outside playing with him. Okay, so now we've got r sine 3x, sine alpha. Ollie, calm down, Ollie. I'll be out in 1 second. Okay, so I can now equate the coefficient. So I can see that 3 is going to be the same as r cos alpha, whereas 7 is going to be the same as r sine alpha. So let's use those facts. 3 equals r cos alpha, 7 equals r sine alpha. So personally I'd divide, it's just my preferred way of doing it. 10 alpha is 7/3. So I just need to do inverse tan of 7/3. Note we're in radians, it's pretty obscure there, but note we are in radians. So I'm just going to change my calculator to radians. And do inverse tan of 7/3. Okay, I'm getting 1.166 for alpha. I'm just going to check that that's all right and I haven't misinformed you here. 1.166, yeah, and r, well, r is always the square root of that one squared plus that one squared. You can work this out in other ways though. So 9 plus 49, so that's root 58. Good. Right. What have we discovered here? Well, we've discovered that this is actually exactly the same curve as y equals root 58 cos of 3x minus 1.166. Yeah, cool. They've actually rounded that to 1.17 in the March scheme. Did they ask for it to 2 decimal places or something? I don't think they did. No. I'm just going to check because I can't quite see the question. No, they didn't ask for it to a certain degree of accuracy, so we'll leave it like that. Okay, part B, you've got to say how we get from y equals cos x to y equals root 58 cos of 3x minus 1.166. Now this is tricky actually, it's harder than it looks, especially because you've got to give it in the right sequence. It's a sequence of free transformations. Now let me have a go at this. I just remember from bitter experience, if you're ever doing the ax plus b transformation, you don't use BibMaths, you use the opposite of that. We need to translate first by 1.166 to the right in the x direction. Yeah, translate by, I suppose if we write it down as a vector, translate by vector 1.166, but they would accept shift 1.166 to the right. Then we want to squash, or should we use the proper word, compress scale factor 3 in the x direction, parallel to x-axis. And finally, stretch, and this one could happen at any point actually, it's independent of the other two, by root 58 in y direction. I should say by scale factor there. Apologies for my terrible handwriting. Stretch by scale factor root 58 in the y direction. And that should be fine. Hopefully everybody's happy with that. It's a tricky one, that one. You must do the translation before the stretch. It's hard to get full 3 marks, but you probably would have got at least 2, or full 4 marks, probably would have got at least 3. Okay, determine the greatest value of this as x varies and give the smallest possible value of x when it occurs. They ask this question all the time. You can actually do it in your head, I promise you, yeah? Because we're trying to find the greatest value, is it the maximum? Yeah, okay, of this. Okay, well the maximum value, because this maximum is 1, so this maximum is actually root 58. Now where does cos achieve a maximum? Well, normally when this equals 0, yeah, because cos of 0 is 1. So we need 3x minus 1.166 to equal 0, in which case just add it across and divide by 3. And you're going to get your x value, and it's 0.389. And that will give you the smallest positive value of x for which it occurs. And you're good, yeah? Hopefully that makes sense. I'm going to finish this video now. I'll do a part 2 in a second. Well done for listening. Please do ask me if you're still confused about any of this. All the best. Bye-bye.